Okay, let us discuss this problem. So this is again writing mechanism. So we have to write down the mechanism for this reaction. So write mechanism. So you have to write down the mechanism for this reaction. So you see, the reactant and product both is given to you. So this is the reactant and this is the product. You see, what are the changes that is taking place? You see, there is a one molecule of H2O. So this says basically there is a loss of one molecule of H2O. So I think I can lose H2O from here or I can lose H2O from here. So basically one hint I have. So what the hint I have? So first hint I have, there is a minus loss of H2O. And now the medium is acidic, so H3PO4. So this is the acid catalyzed reaction. So I have a hint that I have to protonate the alcohol. So that is a protonation of alcohol. So this is another hint I have, protonation of alcohol. So this is a protonation of OH, alcohol. Is getting or not? Now I have two options. Either I can protonate this OH or I can protonate this OH. If I protonate this OH, and if this losses, so I will have a carbocation here. Now you see what is the change, what you have? You have CH3, CH2, CH2. So there is a branch of CH2, CH3, CH3. And this is possible only if I make a carbocation here and then I do hydride shift. Then I will have CH3, CH2, CH2. And there will be carbocation plus, and this carbocation will be attacked by this oxygen. Now check what is the number of size of cycle. So we will have 1 carbon, 2 carbon, 3 carbon, 4, 6. Let me again. So 1, 2, 3, 4, 5, 6. So 6. So this will be, there will be a 6-membered ring containing the oxygen. Are you getting or not? So this means it gives me idea that I have to lose one OH from here. So let us say what we will do. So we have this compound. So things are easy now. We have to protonate and then I have to lose H2O. So this is a OH. And then you have something like this. Now if you add H plus and there is a carbocation and this H plus OH attacks here, so you will have something like this. So simple. You have OH and then if you okay, so this is the, so let me see. So I have to have something like this, OH2 plus, everybody getting. And now what I have to do is in the next step I have to lose one molecule of water. So if I lose one molecule of water and then I will get a carbocation. Of course this carbocation is a secondary carbocation, so you can think. So this is something like this. So let me write OH this side because I have an arrow that side. So OH. So there is a carbocation. Are you getting or not? Now if I do hydride migration, so if I do hydride shift, so this hydrogen with an electron pair, if I shift this hydride here, are you getting or not? So this step is nothing but hydride shift. So this is a hydride shift step. So if I do hydride shift, so if I do hydride shift, what I will have? I will have something like this. So benzene ring is there, OH is there, and then you will have this hydrogen already shifted. So I will have, so basically there was two hydrogen. One hydrogen is shifted, so now it will have only one hydrogen. So let us say you have only one hydrogen and plus charge you will have. And then you will have CH2, 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 CH3. Now the next step, oxygen has a lone pair. And now this lone pair can attack on this carbon. So if this happens, so now you see what is the size of ring? 1, 2, 3, 4, 5, 6. Containing the oxygen. So you have to have a 6-membered ring. So let us say initially you have a 6-membered ring. And you have one more 6-membered ring. So you will have this and this. And you see, I will have on this carbon, you will have CH2, CH2, CH3 group attached. So on this carbon, you will have CH2, CH2, CH3 group attached. And this carbon, there is a carbon, carbon and then oxygen. So you will have carbon, then again carbon, and then oxygen. So this is the case here. And now this oxygen is attached to this carbon. So this oxygen is attached to this carbon. Are you getting around? So this is the final product. You have CH2, CH2, CH3. So this is a mechanism for this reaction. So what are the important points we have? Say hydride shift. So this mechanism followed by hydride shifts. First step is protonation. Second step is carbocation formation. And this carbocation hydrides. This carbocation is basically a stable. So this is a step from here to here. So what is the driving force for this step? stability of carbocation. This carbocation is basically in resonance with the benzene ring, and that's why this carbocation has shifted. So what is the driving force? So driving force is resonance with the benzene ring. So what is the driving force? So driving force for rearrangement of carbocation is resonance with benzene ring. That is the driving force. So resonance with benzene ring. Are you getting? So with benzene ring. So resonance with benzene ring is the driving factor.